Within the package body, we can call them any number of times or any of the subprograms, but outside the package they are not available. And package body follows forward declaration. It will not follow backward declaration. That is why all the local procedures and local functions must be defined before using them. That is why as a general practice, we will be defining all the local subprograms, that is local procedures and local functions, at the beginning of the package, followed by the subprograms of the specification. All the procedures and functions that are included in the package specification must be defined or included in the package body. Whatever the procedures and functions we have in the spec, all those procedures and functions should have the body in the package body. So we just define the definition part or the specification or the prototype of functions and procedures in the spec. The actual body of these subprograms will be present in the package body. So whatever the procedures and functions we define in the spec, all those should have the body in the package body. The order is not required. Whatever the order we define in the package spec, we need not follow the same order in the package body. The only condition what we have is those procedures and functions that are present in the specification must be present in the package body. The order is immaterial. And we can have extra variables and cursors, exceptions, etc. in the package specification. When we define variables or cursors or exceptions in the package specification, they can be placed anywhere. They can be placed at the beginning of the spec, ending of the spec, or middle of the subprograms. We don't have any restrictions. Whatever is present in the spec, they are public. They are available outside the package also. They can be placed anywhere. But if we are using any variables inside the package body, they must be present at the beginning of the package body only, not at the end of the body or not in the middle of the package body, middle of subprograms of the package body. It should be present at the beginning itself. For local subprograms, local procedure and local functions, they can be defined anywhere within the package body, either beginning or ending or middle of the subprograms, but we should define them before using it. That means we should follow the forward declaration. If you try to follow backward declaration, it will throw error. Next, within the package body, we can have an optional initialization part. Initialization part will have the begin, that is the begin section. The begin section we normally use at the end of the subprograms in the package body. Means first we define all the packaged subprograms which are defined in the package specification along with the local subprograms if any, and then at the end we define the optional initialization part. We will use begin and then we can define whatever we require in the begin part. But the begin part should not contain the subprograms. We can call the subprograms within the begin part, but we cannot define the subprograms in the begin part. We can include select statements. We can define the variables. We can initialize the variables. But whenever we first invoke the package, the first part which will be executed is the initialization part, which is the begin part. But this initialization part or begin part will be executed for the first time of the packaged call only, not for the subsequent calls of the package. So when the first time the packaged procedure is invoked, the entire package will be loaded into the memory and the initialization part will be executed and kept all those values into the memory. Once the package is loaded into the memory, the package will be available throughout the session. So whatever the initialization parameters set in the begin part, all those values will be available throughout the session for all the subprograms. So whatever the values we set in the begin part, they will be executed only at the beginning of the package for the first time usage. Subsequent calls to the package, the begin part will not be executed. If you want to re-execute the begin part, we need to discard the package from the memory and then reload the memory. Then only the begin part will be executed once again. So that's all we have learned as part of packages as of now. So we have seen the theoretical concepts and the practical sessions with examples for these basic concepts of package. Now let us see the advantages and disadvantages of the packages. First, discuss about the advantages of packages. We can implement modularity. That means we can divide one single program into multiple modules. That is, instead of writing a lengthy 1000 lines of code as a single program, we can divide that into smaller pieces, like small blocks, small begin end sections, and then include them as subprograms inside a package. It can be in the package spec or it can be only in the package body. The choice is yours. If it is package body only, then it is local to the package. If it is in the package spec, then it is global to the schema. But the package spec will have only the prototype. Package body will have the actual body. So even if we have the access, we can see only the package specification content. We cannot view the body content. So when we have smaller components in the form of subprograms in a package, we can reuse these smaller components within the package body or outside the package body. That means we are implementing modularity. Next, data hiding. When we have the access to the package, we can see only specification content. Body content is not visible. That means we are hiding the business complexity or business logic what we have implemented in the package body. The users cannot see the body content unless we give access separately on the package body. Otherwise they can see only the content. They can see only how many procedures are there or functions are there, and that too which are public procedures and public functions. They cannot see private procedures and private functions. Next, we can implement overloading, which I have not yet discussed in this session, but through the package overloading is allowed. Without the package we cannot implement overloading concept. We can implement overloading concept only in packages. That we will see in the next session. How do we implement overloading? The next, I/O, less I/O generation. When we first invoke a packaged procedure or packaged subprogram, instead of loading that particular piece of subprogram from the package, entire package will be loaded into the memory and it will be stored in the memory for the session, for the entire session. Any subsequent calls made to the packaged subprograms will not reload the entire package again into the memory, because the package is already loaded for that session. So in that session, any subsequent calls made to the package will not go for reloading of the package. That means it will generate less IO. It will not generate the IO for each and every packaged call. It will generate less IO. But this will help only within the same session. This will not help for multiple sessions. This is another advantage, generating less IO by minimizing number of times, that is multiple times loading the package into the memory and discarding from the memory. If it is standalone procedure or standalone function, if we call 10 times in the same session, all the 10 times the procedure or function will be loaded and unloaded from the memory. Every time we call, it will load, it will execute, and then it will discard. So this will not be there in case of package.